Hello everyone. So today I'm going to show you how to use Excel to do the lab report task. Okay. For example, we use the DC motor lab as example here. The first you need to enter those lab the measurement is the data, right? We measured in the lab. Okay. The first one was the field winding resistance. Okay, and then we put the name here, and also we need to put the unit there, right? So the unit is ohms. All right, and the second one, okay, the second one is armature resistance. We just copy the name there because I don't want to search the ohm again, so just copy it over and just change it to the armature, and then put the numbers in, right? So this is what we measured from the lab. And also we want to put those numbers in yellow, the frame in yellow, so that to show us, okay, these are the numbers we just entered. Okay, another set of the data will be the under the load data, right? And we measure quite a few variables. First one was the field current, and the unit is amps. Okay, the second one is armature current, and the unit is amps as well. And the next one will be the armature voltage. Okay, the unit will be volts. And the next one is the speed, RPM, and the torque in Newton meter, right? Those are the numbers we measured, and we measure, I think, quite a few sets. Okay, now let's enter all these numbers we got from the lab, so we can just copy over, right? But be careful, okay, don't make a mistake here. Okay, all right. So yeah, then we just spend a few minutes to put all these numbers in. All right. So now all the numbers are entered already. So, and I'm going to show you how to use Excel to do the calculations, okay? I told you before, right? Don't sit there for 2 hours punch calculators. So we have the tools here for us. For example, the first one was the field winding power. Put the unit there, okay? And also, yeah, and if you need to put a formula there, in that frame, you have to start with the equal, the symbol equal first, and the formula was the RF times IF square, right? And this is exactly what we entered in. Sure, if you want to show the formula, okay, you can type in here as well and just show the formula there. Remind yourself, and then also and give you your reader, okay, basically, right, and very clear. The formula here, so it shows how you get that, how you are doing the calculation, right? How you get that results. So you put the formula in the first frame here, and also, but if you start with the equal sign, and then the Excel will calculate automatically for you. But for the rest of the one, you don't need to enter those formula again. What you do is you just drag in. But before that, you want to make sure the RF is constant. So every single formula you have to use the same RF. That's why I put the $2 signs there for that one variables. And after that, you just drag it over. So they will, the Excel will take in each individual the field current, but use the same, field winding resistance and do the calculation automatically for you. Okay, 2 seconds or 1 second, basically everything's done. All right, okay, and then we can just define the we don't need that many decimal numbers, right? Okay, the second one, so what we do now is we're going to calculate the armature input power. So okay, so and we know the formula will be the armature voltage times armature current, right? Armature voltage, EA, and times IA. Okay, all right, and again, so we're going to use the formula starting with this equal sign, equal symbol, and armature current, and times, and select armature voltage. Okay, it will calculate automatically for us. And again, just drag it over. So for every single test point, okay, it will calculate automatically for us, right? You can see how convenient it is, right? And also it do the calculation very quickly. So you don't sit there punch calculator for 2 hours. All right, the next one will be the mechanical power. Okay, and what is mechanical power? How can we calculate mechanical power again? Remember, torque times speed divided by 9.55, right? Okay, that's the formula. All right. Okay, so we make it a little bit bigger. So, all right. So now same thing. We just type it starting with the equals symbol here, and right, and the torque speed times torque divided by 9.55. That's the formula. Enter. So the finish the calculation already, and drag it. That done. Okay, all the calculations are done. All right, so now let's think about what's the input. This is DC motor, right? The input power will be the armature input power plus the field power, right? Magnetizing power. So the total input power is unit will be watts, right? Equals to the PA plus PF, the armature power plus the magnetizing power. So what you do is start with the equal sign again, and this is the magnetizing power plus the armature power, okay, and the enter. So you finish the calculation again, drag it, all the calculation is done. So next one will be the efficiency. So what's the efficiency calculation here? Will be the output power, and in motor will be the mechanical power, right? The motor, the output power of the motor will be mechanical power. Okay, so will be the mechanical power divided by the total input power. We just calculate. Okay, again use the formula. So equal and mechanical power over input power. Done. Okay, and again drag it again, and then finish all the calculation for the whole set. All right, and again we just choose the resolution only 3 decimals. Okay, so we don't need to want to have a long number there with those, too many decimals, and it's meaningless. All right, so and okay, add all the borders for the table cells. Okay, and it's very good. The calculation is done. Okay, now I'm going to show you how to draw graphs. For example, the first graph will be the the torque versus current. Okay, we choose the current set first and then torque. And then what do? We go to the insert. Okay, go to the insert. Yeah, insert here. And there's the XY scatter. Okay, the manual didn't show you, but there is XY scatter. You choose XY scatter. Okay, and also you choose the manual of the, what do you call it? Yeah, there's a design there. So what you do is we need to add those labels, okay, to those two axes. Okay, and the first, the chart title, we call it torque versus current. So we need to type those text here, right? And without the label, without without those text, without the unit, basically the graph is useless, right? So we need to add those information to your graph. Okay, and also because there's only one graph, you don't need a series. So we need to change this one to the torque, and the unit will be Newton meter, right? So we just type in those numbers there, torque and the Newton meter. Okay, unit is Newton meter. And the next one will be, okay, the x-axis will be the current. And remember the convention, right? Torque versus current, the torque will be on the y-axis and the current will be on the x-axis. Okay, and the unit will be amps. All right. Okay, the next one will be, that's the graph. Right? The next graph we can draw is the efficiency versus power. So mechanical power, for example. So we choose the mechanical power first. We choose the mechanical power, the set of the values of mechanical power. Yeah, and then we choose the efficiency. Okay, we have two sets of number. So when you choose those two sets, you need to press the control sign, right? And choose XY scatter, okay? All right, you get a curve, and they go to the curve design, and they choose go to the curve, the chart, the tools design, and they will find one of those ones with those axis labels here. And again, you need to add labels here, right? Otherwise, it's meaningless. So, okay, the title for our curve here will be, well, we can we can change the size, okay, scale up, scale down size of it. So we put in inside the page, okay. All right, and now we can change the title of of the chat. So now here is the efficiency versus power, right? And again, remember the convention. When you have efficiency versus power, the efficiency should be on the y-axis. Okay, should be on the y-axis. And the power will be on the, efficiency here, and the power will be on the x-axis. Okay, and the unit. Yeah, basically that's it. Okay. Yeah, good luck with your lab report.